Beneath the hazy orange clouds of Saturn's moon Titan lies one of the solar system's greatest mysteries. There is a world down there, much like our own, something strangely familiar, but at the same time, it is alien and unfathomable. So of course, the only way to know for sure what's actually going on out there is to land on the moon and investigate for ourselves. This is exactly what NASA will do with their upcoming Dragonfly mission, a nuclear-powered helicopter that will fly on Titan and search for alien life. What we do know about Titan is awe-inspiring. It's the only moon in the solar system with an atmosphere, and this is a thick atmosphere, 4 times the density of Earth's, and just like on Earth, the majority of Titan's atmosphere is made of nitrogen, but very much unlike the Earth, where we have a nice mixture of breathable oxygen, Titan's atmosphere is laced with methane, more commonly known as natural gas. And that thick atmosphere actually creates a reverse greenhouse effect, blocking out what little heat from the sun can actually reach this far, of ice that is frozen as hard as granite rock. The result is flowing rivers, lakes, and seas of methane flowing all across the surface of Titan, making it the only known world, aside from the Earth, that still has an active hydrological cycle and stable liquid on its surface. Also, like the Earth, Titan has a variety of environments. In addition to the rocky seashores, there are vast deserts across the moon's equator with long dunes formed by blowing wind. Only this is not sand. It's a granular organic material that's also fallen from the sky and settled on top of the frozen ice rock. We have no solid answer as to what this material is, or where it comes from, or if it could potentially support some signs of life given the right circumstances. And speaking of life, Titan has water, lots of it. There is a liquid ocean of water beneath the surface that's mixed with a lot of salt that prevents it from freezing, and occasionally, water will erupt out onto the surface like slushy lava from a cryovolcano. There are also very few impact craters left on Titan, which means that the moon's surface is in a constant state of change and renewal, just like the Earth. So when we put all of this together, water, nitrogen, carbon, and organic molecules, we get all of the right ingredients for life as we know it. Only the environment on Titan would suggest that life couldn't possibly exist here, not as we know it at least. But we also accept that there is still a lot about the universe and the nature of life that we don't know. So we hope that our journey to Titan will return new answers. Now, this is not the first time that we visited the remote moon of Saturn. Everything that we think we know about Titan comes from the Cassini probe that was launched to Saturn in 1997 and studied the planetary system from orbit for many years. But Cassini also brought along a very special bonus payload, a lander called Huygens, named after the Dutch astronomer who first discovered Titan in the night sky. Because of the thick haze that surrounds the entire moon, it's impossible to study Titan from a distance. We need to get up close and personal. Cassini drops Huygens over Titan and the lander begins to fall into the atmosphere, which is not only very thick, but also very high. We used to think Titan was a lot bigger than it actually is, hence the name, because it's bulked up by so much atmosphere. And after deploying its parachute, Huygens spends 2.5 hours floating down to the surface of Titan. It was able to capture these images after finally breaking through the dense haze and coming in for a landing. Remember, these are photos taken with a digital camera from the mid-90s and were transmitted live to Earth over 1 billion kilometers away using the Cassini probe as a relay. So unfortunately, the quality isn't fantastic, but we can see the cliffs of icy rock that have been cut through by flowing streams and rivers of liquid methane. Huygens lands in the soft, sandy bottom of a dried-up riverbed. The last thing it sees before shutting down are these rocks, smooth and rounded by erosion, just like river stones on Earth. Only this isn't rock, it's solid ice. So of course, we have to return to the surface of Titan to find out more. And this is why NASA has developed their Dragonfly rover. It's not like any rover that we've seen before. This one has more in common with a modern quadcopter drone. The only other extraterrestrial location where we've actually flown anything is Mars, which has 37% the gravity of Earth and less than 1% the density of atmosphere. So the fact that NASA was able to fly their Ingenuity drone at all was a pleasant surprise, and Ingenuity was able to complete 72 flight missions on Mars in 3 years of operation. During that time, NASA was able to learn a lot about flying drones from millions of miles away, and they're currently transferring all of that knowledge into the Dragonfly project. Only this time, they're going much bigger. And a bigger drone requires a bigger power source. While Ingenuity was able to get its energy from a small solar panel, Dragonfly will be too far away from the sun and sheltered under too much cloud cover. So to explore Titan, NASA has to go nuclear, which is the same power source that they've been using for Mars rovers since Curiosity back in 2011. This isn't a nuclear reactor like what you may have seen in a power plant. These deep space explorers use a radioisotope thermal generator, which is basically just a chunk of radioactive plutonium that generates heat as it decays, and the generator converts that heat to electricity. Dragonfly is just over 3 meters in length and weighing in at around 450 kilograms. On Earth, that is. But due to the relatively small size of Titan, the gravity there will only be 14% as strong. That's very close to the gravity of Earth's moon. And when you combine that low gravity with the thick atmosphere, it makes flying on Titan a very easy and efficient way to get around. Dragonfly is also an octocopter with 8 propeller blades, each a little over 1 meter in diameter. This design allows for a level of redundancy. The machine doesn't actually need 2 propellers on each corner to fly, but this means that if one breaks, the mission won't be grounded. And that's important because this is a very long and expensive endeavor for NASA. Dragonfly has been in the works since 2017, and it's actually an evolution of an older plan that would have sent a balloon to float around over Titan. As with most complex space exploration missions, timelines can be difficult to pin down. But Dragonfly does have a launch window set for July 2028, and NASA has already booked the SpaceX Falcon Heavy for the job. Now, getting all the way to Titan in a reasonable amount of time is not going to be easy, even with a launch vehicle as powerful as the Falcon Heavy. So, what they're going to do is launch the probe out to Venus first. Then Dragonfly will slingshot around Venus, using the planet's gravity to gain momentum. Then it actually comes back to Earth and performs another gravity assist slingshot to gain even more velocity. And then Dragonfly actually sets course for Titan. This whole process should take 6 years. Dragonfly will arrive at Saturn 1.2 billion kilometers away from the Earth in 2034. The final approach to Titan will be a direct ballistic entry, meaning the vehicle won't settle into orbit and then gradually descend. We are hitting Titan like a cannonball. After separating from its cruise stage engine, the entry capsule is basically just a heat shield with a dome-like cover on top. The heat shield used by Dragonfly is going to be very similar to what NASA used when the Perseverance rover landed on Mars in 2021, and the heating phase of entry should last for about 6 minutes. That's the first moment of stress. Then again, just like with a Mars rover, once the probe has entered Titan's atmosphere, a supersonic drogue parachute will deploy to start bleeding off velocity. This phase should be pretty easygoing. Dragonfly will spend 80 minutes descending on its first parachute. Then, once we're moving at a comfortably slow pace, the heat shield will be ejected and the main parachute deploys. The final descent phase lasts for another 20 minutes. Now, at 1.3 kilometers above the surface of Titan, things get stressful again, because Dragonfly won't be landing with its parachute. Keeping in the same profile as the recent Mars landers, Dragonfly will cut loose from the parachute and deploy its own propulsion system. On Mars, this has been rocket engines, but on Titan, it will be propellers. So it's trial by fire for this drone. Either it works right off the bat, or it drops like a rock. But assuming that it does work, Dragonfly will hover down for a soft landing on the surface of Titan. The chosen landing zone is in a region named Shangri-La. There's a reference to a fictional location in the Tibetan mountains from a 1933 novel called Lost Horizon by the author James Hilton. Interesting choice, given that this region of Titan is more like the planet Arrakis from the Dune series by Frank Herbert. Dragonfly will touch down on a flat plain flanked on both sides by gigantic windswept dunes. These dunes are on average 1 to 2 kilometers wide, 100 meters in height, and they stretch on for hundreds of kilometers. The sand on Titan isn't made of silicates like we know on Earth. It's actually solid hydrocarbons that fall from the sky, so it's kind of like a very hard, grainy snow, if that snow was made from gasoline. Since carbon is the primary building block of life as we know it, these carbon-based grains are considered to be organic compounds, which doesn't mean they are alive, but it means that they might become alive if given the right set of circumstances. What exactly those circumstances are is still largely uncertain, but if these organic compounds are mixing with the subsurface water on Titan, then there could very well be something alive down there. Anyway, that's the first thing that Dragonfly will be investigating. The drone might travel by air, but its most important science will be conducted on the ground. Dragonfly's primary instrument is a drill that will cut into the surface to break up the frozen ground and create a loose dust that can be inhaled into the drone-like vacuum cleaner and transported through a series of tubes into a sample collection device. Every time Dragonfly takes in a sample, it is stored in an individual small container. That container is then transported internally over to a device that will basically shoot the sample with a laser to break the material down into its individual molecules so they can be identified. Then, if the collection of molecules in the sample turn out to be particularly interesting, the container is transported to an oven inside Dragonfly that vaporizes the molecules into a gas that can be even further broken down, sorted through, and analyzed for its specific chemistry. What scientists are looking for specifically are biosignatures. That would be signs of very primitive bacterial life. The idea here is that the conditions we see on Titan right now are very similar to what we believe the conditions of the early Earth were like, where hydrocarbon material fell from the sky and combined with water to form the primordial soup from which all life emerged. That's the theory, at least. So, to conduct this research, Dragonfly will spend 3 Earth years, or 764 Titan days, hopping across the surface, flying over dunes, and landing in the valleys between them. Dragonfly is expected to travel over 180 kilometers and explore 24 unique sites. Dragonfly will lift off once per Titan day, which is every 16 Earth days, traveling in the light and then setting down to collect samples and analyze them until the next dawn. This means the majority of its time will be spent on the surface, taking measurements and transmitting data back to Earth. While the mission begins among the desert's sand dunes, the probe's final days will be spent investigating a large crater known as Selk, where it's believed that organic compounds were able to mix with liquid water following an asteroid impact that broke through the ice barrier. The one place of interest that Dragonfly will not be visiting is the methane seas. In fact, it's unlikely that the drone will encounter any of the surface liquid at all, and that is disappointing, but there's a good reason. It's believed that at one point in time, most of Titan was covered by rivers and lakes, but over the course of billions of years, the surface liquid has retreated almost entirely to the moon's north pole. That's where we would have to go in order to find it, and unfortunately, landing at the polar regions of a planet or moon is about the hardest thing that you can possibly do. We are still really struggling just to land at the south pole of our own moon, so trying the same operation 1 billion kilometers away on Titan would be too much of a risk. Going that far and then crashing would be a disaster for NASA. So, landing at the equator is the simple answer, and with a mission of this scale, simplicity is the key to success. And it's not like Titan is going anywhere. We don't have to do all of the science all at once. In a decade from now, who knows what scientists and engineers might be capable of? We'll have new technology, new rockets, more capabilities to send even more amazing machines out into the deep solar system and discover things that we never even dreamed possible. But Dragonfly is really an amazing first step towards extending our reach far beyond the Earth, and that is something really cool to look forward to.